Okay, so in this one, we've got all three angles taken care of. Using the triangle sum conjecture, that that's called, we know that angle B has to be 50 degrees. Just write 50 degrees in there for angle B. Now, to find lengths A and C, you just have to set up the correct trig ratio, either using sine, cosine, or tangent, as we call a SOHCAHTOA problem. So if I want to solve for A first, A, if I'm using the 40-degree angle, which it's not a bad idea to just use the angle that you were given. Like, what if I was off by 10 degrees or something in my subtraction on the other? I use 40 degrees, I don't have to worry about it. So from the 40-degree angle, A would be considered the opposite, and this would be considered the adjacent. And so thinking about our acronym SOHCAHTOA, which one involves O opposite and A adjacent? Tangent. Yeah, tangent. Opposite and adjacent is right here. So no. Opposite and adjacent would be tangent. So we're going to say, okay, tangent of 40 degrees equals, here it goes again, opposite A over adjacent 2. And then I'll let you go ahead and solve that. So if you could solve that for me, you have your calculators handy, hopefully. So A would be equal to 2 times tangent 40 degrees. You're going to be spending more time in degrees in this unit. Okay, in this unit, these are applied real-life problems. A lot of times we're going to be using degrees. So A equals, we got it, 2 times tangent 40. Make sure you're in degree mode. 1.67. We'll just round to the nearest tenth. I think will be good enough. Now, if I want to solve for C, the ratio I want to use to solve for C, if I'm standing at the 40-degree angle, I would use the 2, not the 1.7, because we were given the 2. We just found the 1.7. What if we made a mistake, right? So let's go ahead and use the 2, which is the adjacent, and the hypotenuse. And of these three ratios, cosine involves adjacent and hypotenuse. So I have a cosine of 40 equals adjacent 2 over hypotenuse C. What I like to do on these, when the variable is in the denominator, is just use the property of proportions that says I can swap diagonally these two pieces. If you'd like, you can cross multiply, then divide. But one of the properties of proportion says I can just swap these two. So C comes up where cosine of 40 degrees is, and cosine of 40 degrees goes down where C was. And so 2 divided by, I should really use squiggly equals, 2 divided by cosine of 40 degrees ends up being approximately 2.6 to the nearest 2. So we have now solved that right triangle. We found all the missing sides and all the missing angles, okay? It's called solving a triangle, or solving the right triangle. So we found C, we found A, and we labeled B on the triangle. All right. Number 2, we are given 2 of the sides, and we only have that one right angle. So to find the third side, probably the easiest way is just Pythagorean theorem, right? So 2 squared plus 3 squared equals C squared. 4 plus 9 equals C squared. So C equals root 13. So root 13 is our C. And then what we have to use to find angles A and B, at least one of those angles is inverse trig. Okay, inverse trig will help us to find A and B. So I could choose either angle A or B. I'm going to start with angle A. And then I'm going to write a ratio using either sine, cosine, or tangent that involves the 3, which is the opposite side, and the 2, which is the adjacent side from angle A. So the one that involves opposite and adjacent is the tangent ratio. So I have tangent of A equals opposite 3 over adjacent 2. This is what we spent a lot of last unit doing, except now we're going to use our calculator, get an output in degrees instead of radians. And the reason we're going to solve this with our calculator is that the arc whose tangent is 3/2 is not one of the ratios that we have memorized on the unit circle. So in our calculator, we type in inverse tangent of 3/2. Do you know how to do that on your calculator? The second tangent. So A should equal about 56.3 degrees. So we can box that. Write it in here if you want. And if A is 56.3, I can just take 90 minus 56.3 to get B. So B is equal to 33.7. This is 33.7 degrees. 33.7 degrees. All right, so that's solving a right triangle. We find all the angles and all the missing sides. So I got a couple of those in the assignment. A few of those, actually. All right. Yeah.
Questions first.
Sure.
How did you flip the C in the cosine of 4 degrees?
Look at those. How did I flip them? Well, it's equivalent to just taking, maybe this will help you. One of the properties of proportion says I can always swap diagonally. That's just the property of proportion. Here's why. If I have cosine of 40 degrees, I can write that over 1 equals 2/c. I would first cross multiply. So this would be c cosine 40 degrees, and then 1 times 2 is 2. Then the next step would be I would divide each side by cosine 40 degrees. These would cancel over here, leaving me with c equals 2 over cosine 40 degrees. So you can see that by cross multiplying and dividing, you get the same thing as you would get if you just swapped these two diagonally.
Okay.
Which is one, I mean, I could swap these if I wanted to, but that doesn't help me. I want c up in the numerator. So just a quick, easy way to algebraically solve for the variable when it's on the bottom, because every time you set these up, it's either here or here, right?
Yeah.
All right. Number 3. This one has a little bit more going on. It says a tourist at the top of the Gateway Arch, height 630 feet, in St. Louis, Missouri, observed boat A moored on the Illinois side of the Mississippi River, 2,070 feet directly across. And I have the diagram up there. You might want to add, I think I put it on there. So you can see directly across. That's from the bottom of the arch all the way across the river. Okay, it's 2,070. And then the height of the arch is 630. I have that marked on there as well. Now the angle, alpha, is 39.4. It's the angle between those paths to A and B. It's kind of like a imaginary little line of sight, if you will, okay, from A to A or to B from the top of the arch. And so on this one, what you have to do is do a little bit of work with this entire right triangle, which I'll highlight right here. I can highlight it here. This entire right triangle right here, do you see that? Before I can then work with findings, for example, the length from here to here, and then the length ultimately from B to A. So I can't directly find the length from B to A with the information given and with just right triangles, okay? We'll learn a way to do that with certain information given with the law of sines or law of cosines. But right now, we're going to think of this as 2 overlapping right triangles. The one I highlighted here, and then this smaller one right here, okay? So the big one, you can see we have the 2,070 and the 630. And so with that information, I can actually find, also I know alpha is 39.4, I think it said on there, yeah. With this information, we can find this entire angle from here to here. Let's call that entire angle theta. So by setting up, which ratio involves the 2070 and the 630 if I'm treating theta as my angle? Tangent, yeah. And tangent is used often. Tangent is kind of like rise over run in your slope. Okay, so tangent theta is equal to opposite 2070 over adjacent 630. And so theta equals inverse tangent of 2070 over 630. So if you plug that into your calculator, inverse tangent of 2070 over 630, you end up getting approximately 73.1 degrees. That's the whole angle. Now keep in mind, alpha is 39.4. That's just from here to here. So if the whole thing is 79 or 73.1, then I can find this little angle, maybe we can call that beta, by subtracting the two. So what would beta equal? Let's see here. Beta equals 73.1 minus 39.4. So beta is equal to, I got 33.7 degrees. So now I have the measurement here, 33.7, of the angle that's part of this small right triangle here. So here's the reason why I want that angle. By knowing this angle and this one side length of the small right triangle, I can find this length from here to here. You with me? If I know this length and this total length from the bottom of the arch over to the boat over here, I can calculate this length right here from B to A. So that's the goal. And this is one way to do it. There could be others. You can choose your own answer on these. So this is from the 33.7, I would call this the adjacent, and this is the opposite here. And we're going to find the length of that opposite by using tangent again. So tangent 33.7 equals opposite. We'll call that x. Opposite can be our x from here to here over adjacent 630. So x over 630. And then if I cross multiply and solve that, I get the length x. X equals 630 tangent 33.7, which equals 420.2 feet. And so the length of my river from here to here is going to be the width of river, length across river, whatever, is 2070 minus 420.2. And that ends up being 1,649.8 feet. That's it. So it's seeing that as two overlapping right triangles. That's the key. And understanding, okay, if I need to find the length from B to A, and I know this whole length, I need to find this piece so I can subtract it off. So think in terms of right triangles. We're only dealing with right triangles here, so you got to find out what the right triangles are and find those missing side lengths. All right, one more here. Let's do this one more. Might wait on number 5. But it says a person observes a lamppost with an angle of elevation of 12 degrees to the top of the lamp and an angle of depression of 7 degrees to the bottom. So let's draw a line of sight here. We'll go straight there. So you could look up to the top of the lamp. That's called the angle of elevation. This is the angle of elevation. And the angle of elevation was given to be 12 degrees. From here to here. Then to the bottom of the lamp post, that's called the angle of depression. and that is 7 degrees. We're also given that the eye level is 152 centimeters. This is not to scale here. The eye level, so from here to here, is 152 centimeters. So 152 centimeters. So there are a couple pieces we need to find. One of them, to find out how far away he is, we need to find x, this distance from his eye to the lamppost. It doesn't matter if it's down here at the base or up here at the top or straight from his eye to the post. We're just going to think of this as one vertical line, even though the lamp has some thickness to it there at the lamppost. We also know that if that's 152, we know from here to here is also 152. And so if we can find just this little piece from here to here, we'll call that y, then we can figure out the height of the lamppost. Alright. So any ideas on how we could find x using that bottom right triangle right here? What setup would help me to find x? Tangent again, yep. X is the adjacent, 152 is the opposite. 7 degrees is my angle, so tangent 7 degrees equals 152 over x, opposite over adjacent. And this is the one we get to use our swapping here again, right? So x equals 152 over tangent 7 degrees. So x is about equal to, talking about centimeters here, so it ends up being a 7 degrees is, you're looking quite a ways out. Just 7 degrees down, so quite a ways out. But it's 1,237.9 centimeters. So that's our x. And then once we have that value x, we could go ahead and do tangent again to find y. So we could say, okay, tangent of 12 degrees now is going to be equal to the opposite, y, over the adjacent, which I just found to be 1237.9. And by cross multiplying, I have y equals 1237.9 times tangent 12 degrees. So cross multiply, and we get y equals 263.1 centimeters. So if y is definitely not the scale, it looks like the 152 is the longer one, but 263.1. So the total length or height of lamp is equal to 263.1 plus 152, which ends up being 415.1 centimeters. So those are examples of some right triangle problems. I actually have